Nomenclature. Nomenclature is basically a fancy word for naming chemical compounds. Here are 3 examples of hydrocarbons or organic compounds that you will be able to name later on in Part 4. You have multiple goals here in Part 1 for naming ionic compounds. First of all, you need to know what an ionic compound is. Okay, what does it have in it? And you should recall from last unit that it has either a metal and a nonmetal or hydrogen and a nonmetal. You should know how to balance ions using coefficients. And coefficients are basically the numbers of ions. You should know how to name the 3 types of ionic compounds if I give you the formula or I just give you the elements involved. And last thing you need to know is you need to know how to write the formula if I give you the name by using the subscripts and coefficients. And those will become important later on. Okay? So let's take a look. So what are ionic compounds? First of all, an ion is an atom that has a positive or negative charge. We know this is due to the fact that it's either gained or lost electrons. And when that happens, you form ions, either positively charged or negatively charged. The positively charged ions are called cations, and anions are the negatively charged ions. So naming ionic compounds. Well, the cation is always written first. So that's the first rule in naming ionic compounds. The second rule is the anion is always written second. And the anion's name changes the ending to "ide." Okay? Last thing that needs to happen is your charges for the ions need to balance out to an overall charge of 0. So here's some examples of some cations and anions. Notice how the cations, the name, is just straight from the periodic table. So hydrogen, lithium, sodium, potassium, cesium, beryllium, magnesium, so on and so forth. Okay? The anions, we take the name from the periodic table and we change the ending to "ide." Okay? So sometimes hydrogen makes an anion, but not very often, and we change the ending to hydride. Fluorine, we know, makes a -1 charge, and we change the ending from fluorine to fluoride, so on and so forth. Now, here's some practice with ionic naming. First thing you need to do is to balance the ion pairs. Okay? And when you balance the ion pairs, you balance them using coefficients. And coefficients are the numbers out in front that tell us the numbers of ions. Okay? So let's take a look at these 3 examples and I'll show you what the coefficients are. Okay? So lithium, recall from the periodic table, makes a +1 charge, and nitrogen makes a -3 charge. Okay, so let's just write that real fast. Lithium makes a +1 charge, plus nitrogen makes a -3 charge. Okay? Now, how many lithiums do I need in order to balance out the 3- charge of the nitrogens? Well, I need 3 of them. This 3 right here is my coefficient. And this 3 in the formula will be written down here as a subscript. Okay? This is a subscript. This is a coefficient. Notice how they are the same. Okay? Now, naming this, it would be lithium nitride. Okay? Lithium nitride. All right, take a look at the other 2 and see if you can do it. So pause the video and I will give the answers momentarily. So here are the answers. Mg makes a +2 charge, and chlorine makes a -1. Rubidium makes a plus charge, and sulfur makes a 2- charge. So how do I write the formula? Okay, Mg, I only need one of them. Chlorine, I need 2, so that 2 becomes the coefficient. Rubidium, I need 2 of these to balance out the 2- charge, and it becomes just like that. Okay, the name, recall, the cation is always said first, and it comes straight from the periodic table. And the anion, the negative charged ion, is the one we change. So lithium nitride, magnesium chloride, and rubidium sulfide. Okay? Now, here's a trick in getting first of all, the coefficients, and second of all, our subscripts. Okay, remember that the coefficients become the subscripts in the chemical formula. So for instance, let's take the coefficients for this. Okay, and we have aluminum, which is +3, and oxygen, which is a -2. So we do something called chargy switchy, and we take these charges and we put them out front, and those become our coefficients. So we have aluminum, we need 2 of them for 3+ charge, and we need 3 oxygens. Okay? Now, notice how the charges balance out to 0. So we have 2 aluminums with 3+ for a total of +6 charge, and we have 3 oxygens at a 2- charge, which give us -6. So +6 -6 equals 0. Okay? Do the same thing here. Okay, this is just a very fast shortcut. Okay, when given the formula or given the ions. Okay, remember the 3 becomes the negative charge, and the 2 becomes the positive charge. Now this won't work if you have something that has the same charge. Okay, so for instance, if you had magnesium +2 and oxygen -2, chargy switchy, notice how they're the same charge anyway, so they're going to balance out to 0, but it would not be correct if you wrote Mg2O2. Okay, that just doesn't make sense. So we write MgO. Alright, moving on. So here's some more practice. Again, pause it, figure out the ion pairs, the formula, and the name, and I'll give you the answers when you are finished. So pause now. So your balanced ion pairs are 2Al3, 3O2-, 3Ca2+, 2P3-, and Ga3+, and 3F-. So the formulas, again, the coefficients becomes the little subscripts. Al2, O3, these 2 3's become subscripts. The 3 and the 2 become subscripts. And this is a 1 here, so it doesn't have 1 here. We don't write 1. We know it's understood. And then the 3 for the fluorine. So how do we name these? Remember, cation, straight from the periodic table. Anion we change to "-ide". So, aluminum oxide, calcium phosphide, gallium fluoride. Okay, we're going to add one more rule here. we're going to start naming with polyatomic ions. So first of all, we need to define what a polyatomic ion is. So polyatomic ions are any ions that are composed of two or more elements that act as one. Okay? They either have a positive or negative charge. Positives are the cations, negatives are the anions. Most of them, however, are anions and they have negative charge. Most end in the suffix "ite" or "ate." So how do we name these? It's basically the same as we did before, except we use the polyatomic ion name instead of "ide." Okay? If there is more than one polyatomic ion needed for the balanced ion pair, then we use parentheses to say that we need more than one. And the coefficient in the balanced ion pairs always goes after the parentheses. So for example, calcium is a 2+, chargy switchy. Okay, so we need one calcium and two nitrates. So we use these parentheses, okay, to say that we need two nitrates. So this little 2 comes from that 2. Okay, and the little 3 stays put. Alright, so moving on. Polyatomic ions. Here is an example of a table of all the different ones. I will give you the table to use on a test or a quiz, so you don't need to memorize. However, it is very helpful to know where they're located and know what each one stands for. So if you have nitrogen, it's always going to be nitrate or nitrite. Sulfur, it's going to be sulfide or sulfate. Okay, phosphorus, it's going to be phosphate, so on and so forth. You have chlorine or chloride or chlorate, so on and so forth. Alright, so the nitrogen or the sulfur or the phosphorus or the chlorine always tell you, or the carbon, okay, it's always going to be the first part of the polyatomic ion name. Alright, now notice how most of them are negative in charge, so most of them are anions. You have one that's positive. Okay, and this is another one that breaks the rule of just taking it from the periodic table. Well, since it's polyatomic, it gets a name, and it's called ammonium. There's also two more exceptions to the rule. You have hydroxide and cyanide. Again, those are the ones that end in "ide." They don't end in "ite" or "ate." Okay, so just know what those mean when taking a look at the polyatomic ion chart. Okay, and don't think that those come straight from the periodic table, because nothing starts with hydroxide and nothing starts with cyanide. Okay, so here's your practice. Okay, I'll give you the elements, I give you the charges. I want you to write the ion pairs, the formula, and the name. So please pause. Okay, so let's take a look at the ion pairs. We need 3 sodiums and 1 PO4. Okay, notice how we use the chargy switchy deal. Okay, this one we need 3 bariums and 2 PO3s. Okay, so those become our coefficients. Okay, and again, those coefficients become our subscripts. Now, which one of these needs parentheses? Well, if you said this one here, you're absolutely correct, because it needs 2. This one doesn't need parentheses because it only has 1 ion here, okay, needed. So let's take a look at the formula. Okay, That's the way we write it. And finally, just like we did in the past, okay, where we named the cation first, and then we take the anion, except the anion comes straight from that chart, okay, instead of, we don't need to do any work by changing the name to ide. It's already done for us. So we just take the cation, which is sodium, and the anion, which is phosphate. We take the cation barium, and we change it to, and the anion we use as phosphite. Okay? Take a look at this example. Please write the balanced ion pairs in the formula. So pause. So the balanced ion pairs are this, and here's the formula. Okay? So how do we do this? This is another skill I'm going to ask you to do, taking the name and going backwards and writing the formula. You always need to do this step, okay, when going in either direction. Okay, so aluminum we know has a +3, and nitrate has a -1. So we do the little chargy switchy dealio, okay, and this gives us the coefficients become subscripts. Okay, there's a little 1 there, but we don't write the 1 because we know it's understood. Now, the third type is using the transition metals. Okay, and the transition metals always give students a lot of trouble. Polyatomics give some students some trouble, but transition metals for some reason gives students a lot of trouble. So I'm going to try my best to explain it to you so it's not so hard. Okay, so what is a transition metal? We know transition metals are in the middle of the periodic table and they have various charges. Okay, their charge indicates a middle name that we're going to be using to name them, and we denote the middle name by using a Roman numeral. So you need to know how to write your Roman numerals all the way up to 4. Okay, so let's take a look here. For example, iron 3 tells us it's a 3+ charge. Iron 2 tells us it's a 2+ charge. Remember that the Roman numeral refers to the charge. Okay, just to reiterate. Some students think that the Roman numeral tells us how many ions are there in the formula, and that's not true. Okay, it tells us the charge. So that's where the pitfall is. So don't fall in that trap. Here are a chart of cations made by the transitions. Okay, you need to understand what these little Roman numeral means. And like I said, you only need to go up to 4. Okay, so this would be 4. All the other ones are 1 and 2 and 3, so on and so forth. Here are 2 that are kind of tricky. We'll talk more about those later. But those we're not going to use very much. All the other ones we're going to use because they follow the rule. You don't need to understand what the older names are. We don't use these anymore, but they're there just to take a look at. Okay, so here are the transition ion charges. Notice how they're in the middle of the periodic table, and they do not fit any kind of pattern like the other ones do. Okay, so you need to know where they are, and also given the formula or given the name, you need to be able to figure out the formula from the name or the name from the formula. So, naming with transition metals, remember that they have middle names because they're in the middle of the periodic table, and the middle names are the Roman numerals. Okay? The Roman numeral, again, tells you the charge, not the number. That is a classic mistake, so don't fall in that trap. Just like before, you write the balanced ion pairs to determine the formula, and here are 2 examples. Okay, so iron 3 oxide, notice the 3 becomes the charge, okay, and notice the 2 here becomes the charge, okay, not the numbers, Okay, if that were true, this would be a little 3 right here. Okay, so this 3 does not exist. All right, so don't get in that habit of doing that. That means it's the charge, and you need to do the balanced ion pairs in order to figure out the formula. Okay, so here's your practice. You have lead 4 hydroxide. Hydroxide is going to come from the polyatomic chart. Okay, carbonate again is going to come from the polyatomic chart, and acetate is going to come from the polyatomic chart. So go ahead and write the ion pairs and also give me the formula. So pause, and in a moment I will give the answers. So here are the answers. You have lead 4, okay, which is a +4 charge, and then you need 4 hydroxides. Iron 3 carbonate, okay, iron 3 means it's a 3+ charge. Carbonate is a 2- charge. We do the little chargy switchy, okay, where these charges become coefficients. Do the same up here. And now we're ready to write the formula. So once we have the formula, okay, we double check and make sure everything is intact. And we make sure we have parentheses. Okay, so since we have 4 of these, 3 of these, and 2 of these, we definitely need parentheses. Okay, alright, now if there was a coefficient of 1, then we would not need parentheses. Okay, so moving on, here's some more practice. Take a look at the formula, and now I want you to write their names. In order to get there, you need to remember your balanced ion pairs, because your balanced ion pairs will tell you the charge of the ions involved. Okay? So take a moment, try to figure it out. You might need to use your polyatomic ion chart in order to determine what the charges are of each ion involved. Okay? And then that will tell you how to name them. If once you have the charge, then you can name. So pause right now. So here are the answers. So when we do the little chargy switchy, this becomes a 2+. Okay, since there's no subscript over here, then we know that that's going to be a -1. Okay, and we can get that information based on the polyatomic ion chart. So this becomes a +2, so therefore we're going to have a Roman numeral. Okay, same thing with this. We do the little chargy switchy, and this one we don't need to do the chargy switchy because the charge is already balanced out to 0. So how do we name these? Okay, well, the first part naming them is the charge, and the charge becomes our middle name. So taking a look here, we have zinc 2 acetate, copper 2 phosphate, and then copper 1 chlorate. Okay, so remember that the 2 refers to the charge, this 2 refers to its charge, and the 1 refers to its charge. So that's how you name ionic compounds. Again, it's going to take a lot of practice. We're going to do lots of practice doing this, but here are the basics. Okay. Nomenclature.